We're going to do part 2, which is solving quadratics with the square root method, but this time we're going to do from vertex form. If you notice, all of these have a parenthesis with a squared, and that means that they are in vertex form. And this works a little differently than standard form. Vertex form again has the parenthesis, and my goal is to get x alone. So these are different because x is trapped in a parenthesis, so I have to undo PEMDAS. And in PEMDAS I'm working backwards when I undo. So I would do exponents before I do parentheses. So to undo the squared, I need to square root both sides. And a square root and a square cancel, so I have x minus 3 equals. 16 is a perfect square. It's 4 times 4. And I have students all the time that still write the square root of 4. They are a pair, plus or minus, because I took a square root, and 4 is free. There is no square root anymore. Now, this is where they also mess it up because I have two problems here. I have x minus 3 equals 4, and I also have x minus 3 equals negative 4. I have to work the problem both ways. Quadratics have two answers. So I'm going to add 3. So I'm going to get x equals 4 plus 3 is 7. I'm going to add 3, and I get x equals a negative 1. And in order to check that, I'm going to put it in the graphing calculator. To do that, I'm going to have x minus 3 squared, and I have to move the 16 over so it becomes a negative 16. When I hit graph, I see that one x-intercept is at negative 1. 1, 2, 3, 4, 5, 6, 7. The other one's at 7. I can check in the table. Negative 1, 0, that is an x-intercept. And 7, 0 is also my other intercept. So I've done that problem correctly. So I'm going to do the next one. Here, the difference is I have an A, C, D is already on the other side. And I'm not going to distribute because I would have to do the squared first. My goal is to get this alone, so I'm going to divide out the 3. So that will leave me with x minus 4 squared equals 5. Again, I do not want to distribute that 3. This is vertex form. Get rid of it by dividing because it's multiplying. Now I am ready. I need to get rid of the squared, so I'm going to square root. So I have x minus 4, square and square root cancel. Plus or minus 5 is 5 times 1. It is prime, so I'm going to leave it as the square root of 5. I cannot break it down. It is not a perfect square. So that leaves me with one more step, one more option, and I do have to get x alone. So I'm going to add 4 to both sides. 4 and the square root of 5 are not in the same like term idea because 4 is free and 5 is under a square root. So I'm going to write 4 plus or minus because it belongs to the square root of 5. And that is my answer. What that means is I have 4 plus the square root of 5. It is a decimal. I also have 4 minus the square root of 5. So I've got just past 6 and almost to 2. When I go to y equals, I would type in 3x minus 4 squared. Again, I have to bring the 15 over, so it is minus 15. And when I hit graph, this one looks like it's hitting right at 2, but it's not. If you put it in your graphing calculator or you look very closely, you can see it's just before the 2, and it is just after 3, 4, 5, 6, just after 6. And when you look here, it was just after 6 and almost to 2. That's how I know I've done it correctly. Again, I'm looking for the x-intercepts. Number 8, there is no a, so I don't have to divide by a. I just want to get rid of a square, so I square root. So I have x minus 4 equals plus or minus. I have to break down 42. It is not a perfect square, but it is also not prime. And I know that 6 times 7 will be 42. 6 is not prime, it becomes 3 and 2. In this case, nobody's a pair. So I guess I actually didn't have to break down 42. So that's going to be 6 times 7 is 42. Nobody was a pair, so nobody comes out. I'm going to add 4 in order to get x alone. Always put the number you moved over first. Plus or minus belongs to the square root. They are 1. So you leave the plus or minus in front of a square root. Okay, we have one more problem, and I'm going to write it down here, 5x plus 1. So that you can see it worked without everything in the way. I have no a, so I don't have to divide. I'm going to go ahead and square root, so I've got 5x plus 1 equals 25 is 5 times 5. It's a pair. It's a perfect pair. 25 is a square, so I have plus or minus 5. That means that I have two problems because this guy is free. There is no square root. 5x plus 1 equals 5. 5x plus 1 equals negative 5. That 5 is positive and it's negative. The problem does not change, just like with absolute values. I'm going to subtract 1. So I got 5x equals 4. Divide by 5. So x is 4/5. It is a fraction. Over here I'm going to subtract 1. Got 5x equals negative 6. I'm going to divide by 5. So I've got x equals negative 6/5. Both are fractions, but those are my two solutions. I have two x-intercepts there. In order to check it, we have 5x plus 1 squared. And I have to bring the 25 over, so it's negative 25, and when I hit graph, I see two solutions. I don't know exactly what they are. It looks like it's 1, but we'll see. So we'll do 4 divided by 5, 0.8, that's definitely close to 1. And then I've got negative 6 divided by 5. So when I go back and look, I'm looking at 1.2. I'm sorry, negative 1.2, which is right there. It looks like it's on negative 1, but it's really not. It's really not on negative 1. And it looks like it's at 1, but that's 0.8, and you can check because at 1, it's not 0. Y is not 0. And at negative 1, y is not 0. So it's definitely decimals, and it should be the two that we got. Same assignment for vertex form as standard, so you can go through and find the ones that are in vertex form and complete those.